Any ideas? Okay, so is X a hard number to figure out because we're just tired at the end of the day, or is it not possible, or are you just being shy? What do you think? It's not possible because anything times zero is zero. Same thing. Same thing. What do you guys think? Is this so quiet because it doesn't feel possible? Or you're realizing it's definitely not? Okay, true. So if we look at this, this rule follows the setup of the one up above, right? So the rule that is written here follows the same setup. So you would figure that, well, that's got to work too, right? However, there's a problem with this information. And the problem is that anything times zero is zero. So this right here always equals zero. So this is impossible, isn't it? Okay, so this is not possible. And it's not possible because anything times zero is zero. And if we look over here at this side, if you remember your zero rules, which some people remember them very easily, a number divided by zero, you can't do that math problem. Okay, so if I looked at this and said 6 divided by 0, like if I tried, and you don't have to do this, but if I tried to do the math of 6 divided by 0, is there anything times 0 that would ever equal 6? This is not possible, right? So a number divided by 0 is not something that could ever happen. So make a note on your paper that says number divided by 0, not possible. We talked about it for a tiny bit when we first started going through slope, because sometimes your rise or your run could be a 0, but it was a very, very small amount of time, and it was a while ago if we did. All right, so a number divided by 0 is never possible. 0 divided by a number is. We'll make a little note. 0 divided by a number equals 0. So like 0 divided by 5 is 0. 0 divided by anything is 0. Okay, so with this warm-up, a couple things that I want to make sure we cover. Just because the rule fits for this situation doesn't mean it's going to fit for every situation. Okay, and that's something that we're going to kind of run into a little bit today. And remembering our rules of dividing by 0, because it is going to come up today, and we're going to have to be able to remember how to handle it. Okay, so it's very, very important to remember a number divided by 0 is not possible. Okay, I feel like when we talked about this before was something like number 0, like you could think of this as like an NO, no, not possible. Number divided by 0, not possible. All right. Okay, so for the next part, we're actually going to work online. So you will need your math notebook. So open up your math notebook, and we're going to open up the Chromebooks. Okay, so in your math notebook, take a second and label the page Unit 5, Lesson 1, because we will work a little bit in it here and there. So Unit 5, Lesson 1. So what you're going to see on your screen is a little machine, and we have an input and an output. The little pink machine is your rule or your input machine. So if you notice, it says input 15, and there's like a table, right? So it says input 15, output question mark. So did you hit the button that says try it? So hit the button that says try it. And see what you get for an output. And then what I want you to do on your paper is you're going to make a little chart with your input and your output. Okay, so, and we'll get back to the question that it asks too. So on your chart, you're going to write, you're going to make a little table. It says input, output, and you're going to input the number that you were given, 15. And what was the output? 5. Okay, so the next thing that's happening on your page is you're asked about rules. Okay, so we want you to come up with which rule do you think was applied to get from 15 to 5. Okay, so 15 became 5, how? Divide by 3, subtract 10, take the ones digit, or divide by 2, then add 5. So pick all the ones that you think could possibly be a rule. Okay, it could be all of them, it could be more than one, it could be just one, but pick all of the rules that you think were applied here or could apply here. So if you start with 15, could you have divided by 3 to get 5? Or could you have started with 15 and subtracted 10 to get 5? Or could you have started with 15 and taken the ones digit to get 5? Could you have divided by 2 and then added 5? So which of those rules could possibly be rules that would work here? Okay. All right. Now you should see the next screen. The next screen has the input and output from before, but now it has a blank row. So in that white blank area, you're going to type any number that you want. So any number that you want, you're going to type into that white box, and you're going to click try it, and you're going to see the output that comes out, and then you're going to put it in your notebook. So enter whatever number you want, click try it, and then see what happens. And you're going to write it down in your math notebook. I'll write mine down. Then you're going to decide which rule made both happen. So now we're going to kind of narrow down our options for the rules. Which rule got you from 15 to 5, but it also had to get you from the number you just put in to the output that you got. So what rule happened that worked for both of your inputs, outputs? Right, so somebody give me one of their inputs and outputs. Camille. 16 and 6, okay, another one. 77, 67. Now you don't have to copy all these down, you can just look up here. Okay, what some other ones? Akil? 40 and 30. Okay, what else? Yes, Annabelle. 24, 14. Okay, so if we look now, these are just random inputs from people in class and then the outputs they got. So if we look at the rules that were the options, does divide by 3, it worked for the first one, right? So divide by 3 worked here, but does divide by 3 work for all of these? No. Okay, subtracting 10. Subtracting 10 worked for the first one. Does it work for all of these?
Yes.
Yes. So if I take my input and subtract 10, I get my output every time. What about ones digit? Does the ones digit still work? If I take the ones digit, 5, ones digit, ones digit, ones digit, ones digit. Did anybody have one where the ones digit didn't work? Nobody had one where the ones digit doesn't work? 43 and 33, nope, that one would. Now, here's the thing about the ones digit. When it says take the ones digit, that means that the output is literally the ones digit. It doesn't mean that it's the ones digit matches up here. It means like, see how the ones digit in 15 is 5? Your output's 5. 25, the ones digit would be 5, so the output should have been 5. So the ones digit rule doesn't work for all of them. It works for some, like if you look at this one, the ones digit is 6 and my output was 6. So if you had like 15 and 5 and 16 and 6, you could have still thought that the ones digit was the rule, right? If you look at the other ones, my ones digit is the same. However, the rule saying ones digit means that if my ones digit is 7, my output has to just be straight 7. And that doesn't work, right? So right now, the only rule that's really possible is subtract 10. Right? So in your notebook, make a note that says subtract 10 as the rule. And in Desmos, mark subtract 10 as our option for our own, that's the only option for the rule, subtract 10. All right, next up, rule number 2. So it says, here is rule number 2. Rule 2 allows all numbers as inputs. Test several inputs to see how rule number 2 works. Okay, so in your notebook, make a new little chart, and we can say like rule number 2. So you're gonna make a new little chart, and you are going to enter as many inputs as you need to see if you can figure out what the rule is. Okay, and whatever inputs you put online, I want you to put down in your notebook. All right, so go in online and enter whatever input you want. It can be any number. Try it, get the output. Put in another input, try it, get the output. Do a couple until you figure out the rule, and kind of write down in your notebook what you're getting as your results. Okay, so take a minute and do that. Bless you. So go in and try another until you think you know what the rule is. I'm keeping track of mine too. Okay, what do you guys think? We could go on forever and ever. Yes, Brian. So you feel like whatever the input is, the output's always gonna be what? 7. So no matter what the input is the output always 7? Did anybody get an output that was not 7? Everything was 7? Did you try all different kinds of numbers, big ones, small ones, decimals? Did anybody get crazy? Put in like big, huge, crazy numbers? So yeah, you have to just be sure, right? See if you can trick the rule. So no matter what number you put in, you always got 7, and that's our rule. So sometimes the rules are as simple as that. The answer is always 7. No matter what you input, you're always going to get 7. So make a note in your notebook that says the rule output is 7. It can be as simple as that. The output 7. Okay, that can happen too. Doesn't mean anything is wrong with the machine. It just means that the machine is very simple. The output 7. Okay. Now the next one you guys are going to do, you're not going to write in your notebook. Because it's not numbers, it's words. Okay, so what you're going to do is in Desmos, did I give you the screen? No, I did. Oops, sorry. There we go. All right, rule number 3, test some inputs. So you will see single words as your input and check out what the output is. So the first word is hello, right? You guys see hello on your screen? So click try it. And you don't need to write anything in your notebook. You're just gonna look at your screen. So you inputted hello and the output was a capital P. Okay, so try another and you're going to enter in a word. You can enter in big words, small words, words with, some words have a space, right? Don't want to type sentences necessarily, but you can type in words, you can type in, they can be as big or as small as you want. And I want you to keep trying until you can figure out the pattern, because there is one. All right, so there is a rule. See if you can figure it out. Also, do not forget that I can see everything you guys are typing. So keep that in mind. You can be silly, but just make sure you're appropriate. See if you can figure out the rule. And again, you don't have to write this in your notebook. You can if you want, but you don't have to. So see if you can figure out the rule. It took me a little bit too when I was going through the example. I'm like, yeah. All right, so a lot of people got it, right? There's alphabetical situation, right? An alphabetical order situation. So specifically with the alphabet, what's happening? I'm trying to see if I can get somebody's up here. You should get mine.
You should do mine. Mine's all long.
No,
I'm doing mine.
I'm look at the day.
If you get mine, you can see my section, the last one.
See if
Probably the last one.
Okay. All right, so let's look at Eric's too here. Yes. Yeah. All right, so if we look at Eric's, now, when I came over to talk to you, it was this section, right?
Yeah.
So when Eric when I went over by him, he saw that each of these returned an F. And I think you noticed about the E's, right?
Yeah.
So, right, so he's like, well, all of my words here, I don't know if you guys can see it, I'll make it bigger. All of the words ended in E and the letter was F. Right? You just can't. Oh, it's too big. There we go. Well, that's really no different, but whatever. So having smaller words does help, especially if you have kind of like an idea that maybe something different is happening. So then you put the alphabet in, and you ended with Z, and then you got A. Did anybody else put like single letters in at some point? I know Camille and I did that. Did you put some in for anyone? So if you put single letters in, you might have been able to notice the pattern. So sometimes when we're finding patterns, because this is important, because there will be times where we do have to figure out what the rule is, and it's not obvious. So if you start small, the smaller you go, sometimes it's a little bit easier to find the pattern. Sometimes it's not as clear, right? You have to kind of strategize a little bit. But hopefully at some point you noticed that if you look at the last letter of your word, the output is the next letter of the alphabet. Okay, so if you look at the last letter of the word, the next letter is the alphabet. So like at the end, Eric did B and got C. So if you did letters, if you put B, you get C. Then if you put D, you get F. And if you notice that something's going on with the alphabet, then go back and look at your words. And you say, okay, well, hello, how did I get a P? What letter does P come after? O, right? So P comes after O. L comes after K. E comes after D. So if you notice that, then you'll see that it's the last letter of every single word is what got us our next word. All right? So the last one, I can't promise you that it's got as easy of a pattern. There is something happening on the last one. So let's try this. Okay, so single letters. So rule number 4 allows single letters. You don't need to write this in your notebook. Single letters like A as inputs. Test several inputs to see how the rule works. Okay, so try a couple to see how the rule works. Yep. Whatever letter you put in, you're gonna get a name that starts with that letter. Do you guys agree?
Yes.
So whatever you enter, if you enter an A, you get a name that starts with A. If you enter W, you get a name that starts with W. Yes? Now, here's my question. With the last rule, if I typed in hello 5 times, I would always get P as the answer or as the output, right? So if I typed in on the last one, if I typed in hello 5 times, I would get the same output every time, right? I'd always get P because we looked at the last letter. Okay, with this one, does everybody agree that we get a name that starts with a letter? Now, for the input A, everybody in the room started with A, right? Did they give you A to start? How many of you guys got Anthony? How many people got a different name than Anthony? So, we have a rule that says that we're going to get a name that starts with that letter, but can we predict exactly what name it's going to be? We can predict part of it. We know that it's going to be a name that starts with A, but we can't predict the exact name, right? So it's still a rule, but it's a rule that's a little bit sketchy because with what we're working with, we need to be able to predict the actual output. With this function rule, can we predict the exact output? No, and that's a little bit of a problem. With our function rules, we have to be able to predict the exact output. Okay, so nothing's broken, but it's a little bit unpredictable, and our function rules have to be predictable. Okay, so that's kind of like the last thing here is that, yes, it does have a rule, but our rules have to be predictable. We can't just be like, yeah, it's just gonna start with an A and then whatever else is there, whatever. We have to know for sure what's exactly gonna happen. All right, so this is a little bit of a problem, but we're gonna kind of see that happen a little more over our lessons too. All right, so close the Chromebook and look back at your packet. You don't have to, yeah, you can sign out or whatever. When you guys open it back up, the next person won't be able to do anything anyway. All right, and then head back to your packet and go to the next page. Are you all good? I'll try. Maybe tomorrow I can go to the office and see if I can figure it out. I'm sorry. All right, you guys. So go to the next page. So we got to have fun with some of the rules online. Now we have to go back to the year 1962 and go to paper pencil. We have to come out of the tech age. All right. So if we look, we have some little function machines. They're not as exciting as the others, but they are still function machines. So if you look at the first one, just so that we know everything that we're dealing with here, we have 3/4 is the input, so label that input. What's in this box is our rule, and then this is our output. Okay, so we have, back to our paper, we have our input, we have a rule, and we have an output. And just like what you guys put in your notebook, we are going to fill in some tables on this page. Okay, so this is our example, right? So we input 3/4, then we're going to add 1 to the number and multiply by 4, and that gives us our output. So we can trust that this is what actually happens to the math. So if we look at our next input, 2.35, take your calculator, and you're going to take 2.35, and you're going to add 1. Oops. And multiply by 4. This is out of the order of operations, but the rule is telling you what order to use, and we're going to use that order. You have to be able to walk up here without stopping and chit-chat. Okay. So I took my number, added 1 to it, and then multiplied by 4. And we get 13.4. And the next number is 42. So our input is 42. We're going to put it in the little machine. Input of 42, and then add 1, multiply by 4. So input 42, add 1, multiply by 4. And we should get done. Oops. 172. No, what did I put in wrong? I didn't clear it out, did I? Oh, it is 172. Okay. I'm losing my mind. Okay. All right. Now, normally I'd have you come up with 2 of your own, but for time reasons, we're going to scoot to the next part. Yes. All right, next one, number 2. Our input is 3/4. The rule is name the digit in the tenths place. And our output is 7. Okay, it's hard to tell from a fraction, so the fraction 3/4 is actually 0.75. So now if we look at the tenths place, tenths is right here, 7. Okay, kind of like one of those first rules where it was taking the ones place. Okay, so now for 2.35, what number's in the tenths place? 3, so my output is 3. With 42, what number's in the tenths place? Don't let it trick you. 0. Not the tens place, the tenths place. If you don't see it, that doesn't mean it's not there. It is there. That's really 42.0. Tenths place is a 0. And again, we could come up with another number, but we're going to go to the next one. Next rule is just like what we saw online. You have an input. No matter what the input is, you're going to write the number 7 as your output. No matter what your input is, output is 7. That can be the rule sometimes. It's just to write a specific number. The last one on this page gets a little bit trickier, but it's really not bad once we think about what's happening. So, number 4, our input is x. Our rule is to divide 1 by the input. So we're saying 1 divided by the input. And somehow they get 1 over x. Fractions are just division, right? So if I look at what happened here, if my input is x and my rule is 1 divided by x, do you see how 1 divided by x can be written as the fraction 1 over x? Fractions are just division, right? Top divided by bottom. Okay, so let's look over here to the side. And we're going to see how this happened. Okay, because I have a 7 and a 3, but they're in the different positions. So let's look at our rule, 1 divided by the input. So off to the side, let me scoot this. We're going to write 1 divided by the input. The input is 3 over 7, right? So 1 divided by 3 over 7. If you remember back to 7th grade and at different points in this school year, when you divide fractions, you actually multiply. We leave the first number the same, change the sign, and you probably heard your teachers prior say flip. Keep, change, flip, or leave, change, flip, something like that. Now, I've been telling everybody we need to start learning vocabulary. This is actually a reciprocal. You guys heard that word? Yes. Maybe here and there. If you go to high school saying flip, teacher's not going to be happy. Okay, we're going to start getting our fourth quarter is getting our vocab straight. Reciprocal. 1 times 7/3, 7 over 3, which is my output. And if you look, do you see how 3/7, if we flip it or find the reciprocal is right there. That's all we had to do is find the reciprocal. So let's look at the next one. 1 divided by the input. What's 1 divided by 1? 1. Last one. 1 divided by the input. Before you answer, think, and then look at the front page of your note packet if you're unsure. 1 divided by 0. Is it 0? Is it not possible? No, not possible. If you look at the front page of your notes, you will see that hopefully you wrote it down. This is not possible. Now, there's a little bit of notes that we're going to take tomorrow because it's about time to pack up. So when you guys come into class tomorrow, there's a little something I'm going to have you copy down in your math notebook. Good job today, you guys. My little function machines. So much better today.
Oh, so.
They did a great job.
I got taken out early.
Oh yeah, Khan Academy, make sure you guys are still working on that. Yeah, keep working on the Khan
And it's
Academy.
7? Okay.
It's quick and easy.
I already had like 5.
Yeah, should be better. Whoa. Out of control. Good job today, you guys.